is a real-life example. This is many years ago now. There was a sex discrimination suit at Berkeley. There was a female professor in the math department, and she was denied tenure. And she filed a lawsuit against Berkeley alleging sex discrimination. Said she wasn't tenured because she's a woman. Now, unfortunately, sex discrimination is a problem in math departments. It's historically been a difficult area. But it's always hard to prove. It's a nebulous kind of thing. They don't say, hey, you can't have tenure because you're a woman. That, they get sued and get killed for that. So she had to get some math to back her up. So what she did is she looked into Berkeley's practices, and she found that in all 22 departments, every single department, the percentage of male PhD applicants that were accepted was higher than the percentage of female PhD applicants that were accepted. Now, you could understand of some of the departments accepting more male PhDs than female PhDs, but all 22? What are the odds of that? I mean, so the immediate conclusion is, well, that's clearly there's sex discrimination going on at Berkeley. Okay? Well, Berkeley took a look at that and said, well, nothing good. That doesn't look good for them. But they did their own study of PhD applicants. And they said that if the university as a whole, look at the university as a whole, actually, the women, the females, have a higher acceptance rate for the PhD program than the men. So look, Berkeley said, we're accepting more women than men, percentage-wise. So how could we be discriminating against women? And this is where the same argument the female faculty member is making, but they're saying as a university as a whole, when you add up all 22 departments, well, that sounds pretty good. How could they be discriminating then? Okay, so the question for you guys, is it possible that both sides were telling the truth? That in every single department, the women have a lower acceptance rate than men, but on the university as a whole, the women are higher percentage. It sounds like it's, and just to avoid any confusion here, people only apply to one department, and they're only one sex. All right, so you can't, Carol, didn't apply, How many people think that one of the sides actually, when they looked at the studies, was wrong? That they're contradictory? Oh, nobody? Yeah, you've been in 602 too long. How many people think it's possible that both sides were right? Yeah. All right, so let's see, how this works. And to make it simple, I'm going to get down to just 2 departments rather than try to do data for all 22. And I'm going to do not the actual data, but something that represents what's going on. Okay, so we're going to look at the following events. A is the event that the applicant is admitted. FCS is the event that the applicant is female and applying to CS. FEE is the event that the applicant is female and applying to EE. MCS is the event the applicant is a male and CS. And then finally we have MEE is the event the applicant is male and in EE. So we're just going to look at 2 departments here and try to figure out if it can happen that in both departments the women are worse off, but if you take the union, they're better off. So the female professor's argument effectively is the probability of being admitted, given that you're a female in CS, is less than the probability of being admitted given that you're a male in CS. And same thing in EE. Probability of being admitted in EE if you're a female is less than if you're a male. Okay? Now, Berkeley is saying sort of the reverse. The probability that you're admitted, given that you're a female in either department, is bigger than the probability of being admitted if you're a male in either department. Okay, so we've now expressed their arguments as conditional probabilities. Any questions? And can you sort of see why this seems contradictory? Right? Because you, well, not plus, union. Because this is sort of like, you know, these are disjoint. This is the sort of the sum of those. Right? And this is sort of the sum of those. And yet, the inequality changed. All right? In fact, this is the logic that we've just debunked over there. Exactly that claim. In fact, these are not equal as the sum. All right? So let's do an example. Say that, well, let's do it over here. I'll put real values in over here. Say that for women in computer science, 0 out of 1 were admitted, compared to the men where 50 out of 100 were admitted. And that in EE, 70 out of 100 women were admitted, compared to the men which had 1 out of 1. All right, so as ratios, 70% is less than 100%, 0% is less than 50. Now if I look at the two departments as a whole, I get 70 over 101 is in fact bigger than 51 over 101. All right, so as a whole, women are a lot more likely to be admitted, even though in each department they're less likely to be admitted. Okay. So what went wrong with the intuition that, which you didn't fall victim to, but people often do, that it shouldn't have been, this shouldn't have been possible given that? What's going on here that makes it so that this is not a less than when you look at the union of the departments? Yeah? Yeah, they're weighted very differently. You got huge weightings here. Right? So if I looked at the average of the percentages here, well, it's 35% for the women versus 75% for the men. So the average of the percentages, just what you'd think, 35 is less than 75. But I've got huge weightings on these guys, which changes the numbers quite dramatically. So it all depends how you count it. Actually, who do you think had a better argument? Yeah, go ahead. Who won the lawsuit? Actually, the woman won the lawsuit. And I mean, which argument would you buy now? You got two arguments. Which one would you believe, if either? Which one? I mean, now, if I look at exactly this data, I might side with Berkeley looking at these numbers. Then again, when you think about all 22 departments and the fact they weren't this lopsided, not so good. So in the end, Berkeley lost. We're going to see another example in a minute where it's even more clear which side to believe in. But it really depends on the numbers as to which one you might, if you had to vote, which way you'd vote. All right, here's another example. This is from a newspaper article on which airlines are best to fly because they have the best on-time rates. And in this case, they were comparing American Airlines and America West, looking at on-time rates. And here's the data they showed for the two airlines. Here's American Airlines. Here's America West. And they took 5 cities: LA, Phoenix, San Diego, San Francisco, and Seattle. And then you looked at the number on time the number of flights, and then the rate, percentage on time. And then same thing here, number on time, number of flights, and the rate. All right, so I'm just going to give you the numbers here. So they had 500 out of 560 for a rate of 89%. 220 over 230 for 95. 210 over 230 for 92%. 500 over 600 for 83%. And then Seattle, they had a lot of flights. That's where they're, maybe they had a hub, 2,200 for 86%. And if you added them all up, they got 3,300 out of 3,820 for 87% on time. Now the data for American West looks something like the following. In LA, it's 700 out of 800 for 87%. They're based in Phoenix. They got a zillion flights there, 4,900 out of 5,300 for 92%. And 400 or 450 for 89%. 320 for 450, 71%. 200 over 260 for 77%. And then you add all them up, and you got 6520 over 7260 for 90%. So the newspaper concluded and literally said that American West is the better airline to fly because their on-time rate is much better. It's 90% versus 87%. What do you think? Which airline would you fly, looking at that data? I know which one I'd fly. I mean, it looks like American West is better. Every single city, American Airlines is better. 92 versus 89. Everywhere it's better by a bunch. 83 versus 71. 86 versus 77. Every single city, American Airlines is better. Yet, American West is better overall. And that's what the newspaper said. They went on this. But of course, no matter where you're going, you're better off with American Airlines. All right? Now, what happened here? The weighting. In fact, American West flies out of Phoenix, where the weather is great. So you get a higher on-time rate when in a good weather city, and they got most of their flights there. American Airlines got a lot of flights in Seattle, where the weather sucks, and you're always delayed. All right, and so they look worse on average because so many of their flights are in a bad city, and so many of America West are in a good city. All right, so it makes America West look better when, in fact, in this case, it's absolutely clear who's better. American Airlines is better, every single city. All right, that's why Mark Twain said there's three kinds of lies: lies, damned lies, and statistics. We'll see more examples next time.